Now let's turn to an example that shows how inheritance can be used to our advantage. We'll start by building an application that organizes information about people, and we'll create a person class, an object that we can use to represent people. In our very simple example, our person will have a name and a birthday, and we'll provide interface methods for getting the last name of a person. We'll provide support for supporting lists of people by their last name, and finally we'll be able to get the age of a person based on their birthday. Let's go look at the code. So here we have our definition of the person class with all the different methods defined for it. We're also making advantage of the datetime module, which is provides a bunch of support for manipulating dates, and we'll see how that gets used in a moment. So let's start by creating somebody. So how about me? So I'm a person, and my name is Chris J. Terman. All right, so if I go off and ask to print me, you can see that the print representation of a person is in fact just their name. If we come down here and look at the string method for a person class, I can see that in fact it just returns the string, which is the person's name. Okay, when we created a person, you can see that it saved away my name. It gave me a birthday of none because it doesn't happen to know what my birthday is at the moment. And finally, it pre-computed my last name. So what it's done is to do a certain operation on the name string. So what it does is to take the name string as it comes in, so in this case, Chris space J space Terman, and it splits that string into substrings using the space as the separator. So in this case, the split operation would have produced a list of 3 substrings that contained Chris, J, and Terman. And then what I do is select the last element of that list as my last name. So now I'm going to go off and get my last name, and because of the way the semantics of this particular class is defined, there's a method for getting the last name. So me get last name, and we can see that in fact it returns to the string that was expected. Notice that I could have done this a little differently. Instead of pre-computing last names, I could have computed the last name on the fly. So that's sort of an implementation detail that should be hidden inside of the person class. And so we provided a method for getting a last name, and you don't really know whether it's computing on the fly or it was pre-computed once when the person was initialized. Let's give me a birthday. So now you can see the advantage of the tooltip because it helps us remember the orders of the arguments. So I'll say July 4th, 1951. So what setBirthday does is to take the supplied month, day, and year. It actually puts the arguments in the right order with a request to the datetime module to create a date object which represents this particular date. And the reason I'm using the date type out of the datetime module is I get support for all sorts of operations on dates by doing so. And so I saved that datetime object away as the value of the birthday instance variable. And this is one of those representational invariants that we talked about earlier. Birthday should either be none or they should be an instance of the date type from the datetime module. Okay, so now what I can do is go off and say, what's my age? Oh my goodness, 22,000 days. Let's see how that works. So the getAge method, well, it checks to see if I've been given a birthday. If the system doesn't know what the birthday is for this particular instance of a person, it basically raises a value error and saying, look, there's a bug in your program. You're asking for the age of the person and we don't know what it is. Assuming that I've been giving a birthday, which I had been given, it runs off and takes the date object where it represents my birthday and subtracts it from the date object that represents the current moment in time. And you can see that what happens is that the date object knows how to subtract 2 dates, and then it returns another date object, which I can ask how many days that object represents. In this case, 22,358 days. Okay, let's define another person, Madonna. Since it would be impolite, we won't give Madonna an age. Great, so now what happens if I ask for her last name? Notice in this case there are no spaces in the string representation of the name. And indeed, we just get the single name back, and that's what we expect here, because the split operation, if it doesn't find any of those separators, simply returns a list with a single substring in it, which was the original string. And then I ask for the last element of that single element list, and I get the name back. So there we are. Alrighty, so now let's make a list of people. Me and Madonna. I can go off and ask to print out for all the people in the P list. Print them out for me, please. And you can see we get the people listed in order here, in the order that I entered them into the list, me and then Madonna. Just for grins, let's go off and sort that person list, like so. And then if I ask for the list again, you can see that, in fact, the list now is sorted in order of their last name. But wait, how does the sort routine, which is a generic routine that can be used for sorting lists, how does it know how to sort people? Let's go figure that out. Okay, so how did plist.sort do the right thing? So Python has a particular sort algorithm for sorting sequences. It's a highly optimized combination of a merge and an insertion sort, which means quite efficient in most real-world lists and has a very good average case performance. So you can say, okay, well, so it uses a really fancy sort algorithm. How does it know how to sort people? Well, the only knowledge that the timsort algorithm needs about the objects that it's sorting, the objects that appear on the list, is it needs to be able to compare two of those objects and get back, using a less than operation, and get back an answer of whether one object is less than or another. So that's the only operation that we have to define on the objects in a list in order for them to be able to be sorted by the sort routine. So inside the timsort algorithm, if it asks if a particular object in the list is less than another object in the list, well, Python translates this expression in the source code, okay, when there's an object involved. In this case, object 1 is the first argument. It translates that into a particular call of a special method, a built-in method for object 1. In this case, it's going to call the less than method. Notice the double underscores at the beginning and end, so that means it's a special built-in method. Okay, so it's going to call the less than method of object 1 and pass it in the second object. And so that all the sort routine really needs is for this to be implemented on the objects in the list, and then the sort method will take it from there. Okay, so we only have to implement the less than special method. So if you want to know what all the special methods are that you can implement and sort of tap into all sorts of great behavior that Python has built in, look at section 3.4 of the Python language reference manual. So if we go back and look at the code, we can see that we have in fact defined that special less than method for person objects. What it does is that it checks to see, well, look, if the two last names are the same, so we pre-computed the last names, so they're available for each person, so we can just quickly check to see if they have the same last names. And if so, we use the rest of the name to create the sort order. We see if one is less than the other simply by comparing the two name strings. However, if the last names aren't the same, we simply look for the correct order of the last names. So off we go. So that implements the necessary operation to support sorting of people when they appear in a list.